Hi guys, this is Mrs. Myers. We're going to do a quick run through on line symmetry. So far we have done transformations and you've learned about reflections. So far though it's been a reflection like if you have a shape over here and you reflect it over a line, you get another shape on the other side that is the reflection of the first one. You end up with two shapes. They're both congruent to each other when you reflect. That's the kind of reflection we've learned about already. This line symmetry is really talking about reflecting an image onto itself. So it ends up with a shape or a figure with symmetry within itself. So if you see our examples down here, like this heart, has line symmetry because you can draw a line down the center of the heart and imagine folding this onto itself. You've probably done this before where you take a piece of paper and you cut half a heart and you open it up and you end up with the full heart, right? So that is a figure that has what we call line symmetry. It's got basically a place where you can fold it and the two halves are exactly the same. Okay? A figure in the plane has line symmetry if and only if the figure can be mapped onto itself by a reflection through a line that goes through the figure. Okay, that line of reflection or line of symmetry or the axis of symmetry, all those terms refer to that fold line in each of these instances. Now, a heart only has one line of symmetry or line of axis of symmetry. You can use both terms there. This letter A only has one, but this figure kind of looks like a flower. There's lots of lines of symmetry. 1, 2, 3, actually 4 lines of symmetry that go through that flower. This one is an equilateral triangle. It has 3 lines of symmetry. 1, 2, 3. Okay, so there can be more than one line of symmetry through a figure. These don't have line symmetry at all. There's nowhere you can fold. Notice when you look at the letter Z, it looks a little bit like it should have some sort of symmetry. The top and the bottom kind of look the same, but there's really nowhere you can fold this. If you fold it here, this side would end up kind of looking like this. Right? If you actually reflected that, and that doesn't look like a Z, right? So this does not have line symmetry. The other one that sometimes fools people is a parallelogram like this, right? If you reflect, say, this part of this parallelogram over this line, it's going to look more like that, which is not a parallelogram, right? So a parallelogram does actually not have line symmetry. You could, it says here, you can use patty paper to trace something and then fold it and see if it actually maps onto itself. So look at the shape and the dotted line. Use patty paper or the folding technique to decide if the dotted line is a line of reflection, and then circle yes or no. So on these, I'm going to pause the video and I'm going to let you do this yourself, and then turn this back on and you can see if you got them right. Okay, so check your answers, see if you got those right. There's a few that were a little bit tricky, but not too bad there, right? Were you surprised by number 6 or number 7? Okay, remember that they have to fold onto themselves. So if you were tricked by those, maybe take your paper right now and fold along that line and see, hold it up to the light, and you can see how the two sides, the two halves don't actually match up. Okay. Number 9 says, is there another way to draw lines of reflection for these shapes? And see if you can. Because 6 and 7, those lines didn't work, but maybe there's another way to do it. For this one, there is. And for this one, could you draw a line of symmetry somewhere else? Not really. That one doesn't work. Okay, for the next ones, decide if each figure has line symmetry. If it does, draw all the possible lines of reflection. If it doesn't, just write none. Okay, so again, try this on your own and then come back and check. Okay, you should have paused the video and done this yourself, but here are the answers. Okay. This next one, a regular polygon. This is a really important term here. This is a piece of vocabulary that you need to make sure you understand. A regular polygon is a polygon that is both equilateral, means the sides are all congruent, okay, equilateral and equiangular. All the angles, let's write out the word angles, all the angles are congruent. So regular polygon, regular, means that all the sides and all the angles are congruent. So regular triangle would be an equilateral triangle. All the sides and all the angles are congruent. A square, it would be a regular quadrilateral. And this pentagon is a regular pentagon. Not all pentagons are regular, right? I could draw like a house with all the sides congruent, but not all the angles are congruent. So that is not regular. So this one is, though, because all these angles are congruent. Okay? All right, so in here, we're just noticing the number of sides and the number of lines of reflection and trying to sort of see a pattern here. This has 3 sides, and it's going to have 3 lines of reflection because it's a regular triangle. Same thing here. It's going to have 4 sides and 4 lines of reflection. 5 sides and 5 lines of reflection. So you should practice drawing in those lines of reflection there. Make sure you can find all 4 here and all 5 there, etc. So all of these are regular, and they're going to have that same pattern. I'm going to let you guys do that one on your own. And so the rest of this page you can finish on your own. It's pretty self-explanatory. Let's look at the back. Look at the regular hexagon below. How can you alter the hexagon so that it only has 2 lines of reflection instead of 6? So you may need to make it irregular. In other words, the only way to do it is to make it irregular. So in other words, draw a hexagon that's not regular hexagon so that it has 2 lines of reflection instead of the 6 lines of reflection. So I'm going to let you try that one on your own also. And actually, why don't you finish this page and then right now, pause the video, okay? Finish this page and then come back and check your answers. Okay, so this first one, if you kind of elongate this hexagon, stretch it out, or make it taller, either way, you have 2 lines of symmetry instead of the 6. Here's some lines of symmetry on, here's the reflections for 2 through 4, and then the lines of symmetry. Notice this snowflake has 6 lines of symmetry because it kind of resembles a hexagon, right? 6 lines of symmetry. Sydney Opera House, not really. Taj Mahal does. This Celtic knot, I put a question mark because if you really go by the what's going over and what's going under, it doesn't really fold perfectly. But if you just took the outline of this Celtic knot, you know, if we shaded this all in one color and we couldn't tell what was going under and over, then it would have 2 lines of symmetry, one horizontal and one vertical. Eiffel Tower, certainly, and this structure here looks kind of like a pentagon and has 1 line of symmetry. Okay, good job, and make sure you are familiar with the vocab and this whole process, and practice any problems that you didn't get to do on your own. Thanks, bye.